This is Professor Pelton. This is Trigonometry, Chapter 1, Section 1, Angles and Radian Measures. For this course, we'll be using the Greek alphabet consistently in all the chapters. You'll be able to refer back to this list as the course goes on, noticing that the Greek alphabet does not have as many letters as the English alphabet, because English, Greek, and other alphabets all have different numbers of letters, so it's not going to be a one-to-one. Okay? The A and the B for alpha and beta might line up, but the other ones do not line up as you would think. Okay. So from geometry we need to know a couple things. First is angles. Okay, so for angles we're still going to have a vertex and a common endpoint and two rays, but what's important here now is we have to recognize that they have to draw an initial side and a terminal side, which just means the side you drew first and the side you drew second, because that'll give us the direction as to which way the angle opened. This is important because the which way it opens tells you whether that angle is a positive or a negative angle, because we care about that in the direction now for trigonometry. Okay, and whether it's free drawn like this one or in a circle, the case is still the same. What we want to do, however, is draw these in standard position, which basically means we're drawing it in R2, which is the second dimension. So let's scroll down a little bit here. So I have two angles drawn down here in standard position. I have a positive angle in standard position and a negative angle drawn in standard position. Okay, which basically means they're both drawn in R2 because they both have an X and a Y axis for 2 dimensions. And just for reference sake from Algebra 1 and geometry, if you're just on a number line, that's R1, right? Because you just have X. And if you're in the third dimension, you would have an X, a Y, and a Z for 3 dimensions for R3. But we'll be working in R2. Okay? And what's important to recognize here is the initial axis is always the positive x-axis. That is always the initial side, and the terminal side determines the positive or negative from there. Okay? And what you can see is with these is that if you look, you can also draw an angle the other way. So there is a negative and a positive angle for every angle drawn in standard position. Okay, whether it's freehand too, so same thing here. There's a positive and a negative angle drawn, and the total should always be 360 degrees. Okay, let's go to the next page. Okay, let's practice drawing standard position angles. So first we're going to need our R2 in each case. Okay, we'll change colors. You can change with a pen or pencil. And the initial side is always on the positive x-axis. 45 degrees is positive, so that's going to go counterclockwise. So this is our initial. This is our terminal side for 45 degrees. Remember, of course, that each one of these axes makes 45 degrees, so therefore half of it would be 45. So for negative, you'd still use the same initial side. However, we're going clockwise this time for negative 45 degrees to the terminal side. Okay, pause the video here and draw your standard position angles and start the video again once you've completed them. Okay, let's try these and see how well you did. So again, let's draw our axes for R2. Okay, so we'll change colors. We'll draw our initial axes. 135 is positive, so that's going to go counterclockwise over to here-ish. So that's 135 degrees. That is our initial. That is our terminal side. Because again, this would be 180 over there. We didn't quite make 180. So negative 135, same initial side. And we'll go this way for negative 135 in the clockwise position to the terminal side. Okay. Alright, let's scroll down, go to the next piece. Alright, next thing we need to do is be able to convert degrees into its component parts called degrees, minutes, and seconds. We have to convert from degrees to DMS and from DMS to degrees. That's our goal here. So what you'll notice on your scientific and graphing calculator is a DMS button on there, and that's what it in fact stands for. And you'll notice the little single quote and double quote is what's used to denote minutes and seconds. Okay, so you can see that there's of course 60 minutes in a degree and 60 seconds in a minute, like a clock. So you could go 1 to 3,600 if you want to go right to seconds if you want to. I'm going to go in pieces and just do 60 a time instead of 60 times 60. Alright, so first is 32 degrees, 0.89. So we're going to take that 0.89 and we'll multiply it by its unit factor, which is 60 minutes is 1 degree, so the degrees cancel, and that'll give us 53.4 minutes. So therefore this becomes 32 degrees in 53.4 minutes. Now we want to get the seconds, so we'll take this 0.4, 0.4 minutes, and we'll multiply that by 60 seconds in 1 minute, and the minutes will cancel, and that'll give us 24 seconds. Oops. Sorry. Let me erase that a little bit there. There we go. Okay, so we have 32 degrees, 53 minutes, and 24 seconds. Okay, so that's going from degrees to DMS. Now let's go from DMS to degrees. So it's going to go the other way. So it's going to flip the unit factor. So we'll take our 30 seconds and we'll multiply that times 1 minute is 60 seconds. So that cancels and gives us 0.5 minutes. Which means I have 46 degrees and 15.5 minutes because we just added on the 0.5 to what we had before. Okay, so we'll take our minutes now, 15.5, and to convert that to degrees. So we have 15.5 minutes, and multiply that by 1 degree is 60 minutes. And that'll give us 0.2583 repeating degrees. So therefore I have 46.2583 repeating degrees. Okay? Alright, take a second and pause the video and try the student problems for yourself. Okay, let's try the student problems. Okay, so we need to go to DMS from degrees. So we have 0.37 degrees multiplied by 1 minute is 60 degrees. Oops, sorry, we're going around. 60 minutes in 1 degree. And that'll give me excuse me, 22.2 minutes. So I have 27 degrees in 22.2 minutes. So then we'll take our 0.20 minutes and multiply that by 60 seconds in a minute. That'll give us 12 seconds. So that gives me 27 degrees, 22 minutes, and 12 seconds. Okay, now let's go the other way. So we have 15 seconds. So that's 1 minute to 60 seconds, which gives me 0.25 minutes. So therefore I have 27 degrees and 30.25 minutes when I add that on to what I had before. Okay, so then we'll take our 30.25 minutes, multiply that by 1 degree is 60 minutes, and I will get 0.50416 repeating degrees. So therefore my final answer is 27.50416 repeating degrees. You notice you'll get a lot of repeating 0.6s and 0.3s because of the fact we're dividing by a factor of 3 on those. You tend to get the repeating a lot. Not always, but when you do, it tends to be that. Alright, let's go to page 3. Okay, so you worked with pi a lot in geometry, which we're going to here, and we're going to be using a lot of things called a radian measure. So a radian is the measure of the central angle of a circle, specifically. And basically it has to do with the arc and the radius of the circle. So basically, when the arc length is equal to the radius, you have 1 radian. Okay? So if I look at the example here where I have the arc length is 2 radius for 1 radius of a circle, how many radians is that? That's 2 radians, which is abbreviated rad. Okay, so the rule of thumb in trigonometry is radian is abbreviated as rad. If there's no measure specified whatsoever, the default measure is rad when not specified for an angle. So it's not given as degrees or something else. The default is radians if not otherwise given. Alright, pause the video, try the student problem. Okay, for the student problem, this would be 3 radians. Is how big that central angle is, basically, because it has 3 radius as an arc length. Okay, let's go to the radian measure formula, and we'll try some problems here. So the radian measure formula says the central angle, which we're going to call theta in this case, you can look back at the Greek alphabet, is S over R, where S is the arc length and R is the radius. So if we have this particular circle here in the example with an arc length of 15 inches and a radius of 6 inches, then the central angle theta, S over R, is 15 inches over 6 inches, cancel, cancel, which is 2.5 radians. Okay, notice when there's no measure left, it becomes radians. Pause the video, try the student problem. Okay, so let's draw a circle for this. And it says here that the diameter is 24, which means the radius must be 12. And it says a 42-foot arc length, so I'm going to guess it's about right there. Doesn't need to be drawn exactly here. So that is my theta. Okay. So therefore my theta measure in radians is S over R, which is 42 feet over 12 feet. Cancel, cancel, which gives me 3.5 radians.
Just a reminder to all staff that have a two-way radio, please make sure you bring it down to the main office. So if you have a walkie-talkie, two-way radio,
Alright, page 4.
down to the main office, CENTCOM.
Okay, so we also need to convert from radians to degrees and degrees from radians. Okay, so let's think about a circle. One circle is 360 degrees all the way around. Right, so we go all the way around, one rotation. That's 360 degrees. which is also 2 pi. Okay, because if the radius is 1, okay, unit circle 1, then you would only get 2 pi all the way around. Okay, so basically 360 degrees is 2 pi. So if you simplify that fraction, you get 180 over pi as the conversion factor or the unit. So if I want to go from degrees to radians, I would need to cancel the degrees. That would be pi over 180, which would cancel the degrees because the degrees is on bottom, and the radians would be on top. If I wanted to go from the other way, which is radians to degrees, I would need to cancel radians, which would be 180 degrees over pi radians, because again I would be canceling radians, so that would need to be on the bottom. So you just use that conversion factor depending on what the problem is. Okay, let's do some student problems. Okay, 30 degrees. So that means we need to cancel degrees. Degrees has to be on bottom. So that's pi radians over 180 degrees. And typically you don't label radians, you just leave it as is. Because if it's unlabeled, again, it's default radians. Let's see, so cancel, cancel. That gives me pi over 6 radians, and we'll label the final answer, although you don't need to in radians. So negative angle, negative 135. Again, we need to cancel the degrees, so it's pi over 180, which will give me negative 3 pi over 4 radians. Okay, then we have pi over 3. So this time we have pi over 3, but we want to convert to degrees. It means we need to get rid of radians. So it's 180 degrees over pi radians. So that'll cancel there, and that'll give me 60 degrees, because the radians canceled. Okay, so you see what we're trying to do here is when it's degrees, cancel degrees, when it's radians, cancel radians. So for example, negative 4 pi over 3 is a radian. So we need to cancel radians by having radians on bottom. So cancel, cancel, and that'll give me, let's see, 3 into 180 gives me a 6. That's negative 4 times 60. So that's negative 240 degrees. Okay, and the last one is 1 radian. That's weird. There's no pi there. Does there need to be a pi? No. Just because there's no pi does not mean it's not radians. So 1 radian, 180 degrees, over pi radians, right? You don't need to put the rads there, but we will in this case. So cancel, cancel, so I end up getting 180 degrees over pi. And if you want to get the decimal answer, that'd be approximately 57.2957 ... degrees, which is not really necessary though. You probably want to keep the exact answer, which is the 180 degrees over pi. Okay, pause the video and try for yourself on the student problems. Okay, let's try the student problems. So we have 270 degrees. And we want to get rid of degrees. That means the degrees need to go on bottom. So cancel, cancel. And that would give me 3 pi over 2 radians. And again, you don't need to label the radians if you don't want to. And negative 300 degrees. Again, we want to cancel degrees, so it needs to be on the bottom. So the 180 degrees goes on bottom. Cancel, cancel. So that would give me negative 5 pi over 3 radians. Okay, next one, pi over 4. So pi over 4 times, again we want to cancel the pi, or the radians, so that's 180 degrees over pi this time. So cancel, cancel. So your 180 over 4 is 45 degrees. Next one, negative 7 pi over 3. So we want times 180 over the pi to cancel the radians. Cancel, cancel. So that'll give me negative 420 degrees. Okay, and the last one says 6 radians, but there's no pi. Just because there's no pi does not mean it's not radians. Okay, So we have 6 radians. We'll times that by 180 degrees over pi radians, which will cancel that and give me 1080 degrees over pi, which is a sufficient answer because it is in degrees. So that would give me approximately 343.77467 ... degrees. Okay? Alright, let's go to page 5. Now we want to convert from revolutions to radians and back. Okay, so what you will notice is in some books they call them revolutions or rotations. So they tend to mean rotations as in multiple times around, where a revolution could mean a partial time around. But it really depends on the book. So some books will abbreviate as rot, and some books will abbreviate it as rev. For the sake of this chapter, we're going to abbreviate it as rev, R-E-V, for revolutions. So one revolution, of course, is all the way around, which is 2 pi or 360 degrees, however you want to look at it. Okay, so let's do a conversion factor here. So 3/4 of a revolution, when you do the abbreviations, always do them in the numerator, even if it is a fraction. So we want to cancel the revolutions. That means we need to put the conversion factor of revolution on the bottom, and we'll put the 2 pi radians in the top. So we want to cancel the revolution. So that gives me 3 pi over 2 radians. Okay, take a second and do the student problems. Pause the video. Okay, let's try the next ones. So we have 1/2 of a rev. Again, put the label in the numerator, because again we want to cancel by multiplying by the denominator. So 1 rev is 2 pi radians. So cancel, cancel. And that'll give us a pi radian, which tells us a 180 degrees is pi, or half a time on a circle. Okay, next one. 1/4 of a revolution. The conversion factor is 2 pi radians over 1 revolution. Cancel, cancel. And that gives us a pi over 2 radians, which tells us 90 degrees basically is pi over 2. Okay, or a quarter turn. Okay, so now we convert the following angles to revolutions. So we went from revolutions to radians. Now we want to go from radians to revolutions and degrees. Okay, so this is a radian, so labeled as rad. So we want to multiply that by 1 revolution is 2 pi radians, and the radians will cancel. And the pi's will cancel. So that'll give us 5/8 of a revolution. So we didn't even make it all the way around the circle. Okay, next one is also a radian. We'll multiply that by 1 revolution is 2 pi radians. Again, the radians will cancel, the pi's will cancel. So we get -3/8 of a revolution. So we're going backwards around the circle, or clockwise, and we didn't make it around all the way again. So the last one is 340 degrees. So we want 1 revolution is all the way around, so that's 360 degrees. So here, the degrees will cancel, and that'll leave me with 2/3 of a revolution. So we almost made it all the way around, but we're a third short. Alright, take a second, try the student problems. Okay, let's try the student problems. Okay, so this is a radian. So multiply that by 1 revolution is 2 pi radians, which cancels, and the pi's cancel. So I get 13/8 of a revolution, which is 1 5/8 of a revolution. So that means we almost made it 2 times around. So the next one, radian. And that gives me 1 revolution is 2 pi radians. Cancel the radians, cancel the pi's. That gives me negative 7/8 of a revolution. So we made it almost 1 time around going clockwise. Alright, and the last one, theta. So we're paying attention, by the way. Alpha, lambda, theta, the letters I'm using from the Greek alphabet. That's degrees. So this is 1 revolution is 360 degrees. Ooh, that didn't work out too well. Let's fix that. 360 degrees. So that'll give me 7/6 of a revolution, which is 1 1/6 of a revolution. Okay? Alright, let's go to the last page. Okay, so I gave you a quick chart of a unit circle, which gives the equivalent degree and radian measures, which you can check for yourself by doing all the conversion factors. I didn't do revolutions. I figure you can do that for yourself, that 1 revolution is all the way around and half and so forth. I didn't bother with the revolutions, but I have the radians degree. So the overall goal here is you should be able to convert radians, degrees, and revolutions from one to any of the others. Okay? Alright, now we have to do coterminal angles. Coterminal angles. Okay, coterminal angles are angles with the same terminal side, because you can go 2 directions in the unit circle. Alright, so the first one is 420 degrees, so that's more than 360, means we're going to go more than 1 time around. So if I subtract 360, I'll get 60 degrees. So that means I went all the way around once, plus another 60 degrees, and I got my terminal side. Okay, so there's my initial side that I started at, and I went all the way around once, plus another 60 degrees. Okay, so this whole angle here, going all the way around, is 420 degrees. Okay, and then we have a little coterminal, so we have one angle of 60 degrees, that's coterminal, and we also have one if we went the other way, of negative 300. So those are the 2 possible coterminal angles, because they both have the same terminal side as 420. So 420, 60, and the negative 300 are all coterminal angles, because they all have the same terminal side. Okay, so let's try negative 120. So the initial side is right here. So you have to go negative 120, which goes this way. So that is my initial angle. So if I went the positive way, this would be 240, because the total has to be 360 going all the way around, because this is the shared terminal side. So the coterminal angle to 240 is negative 120, and negative 120 is coterminal to 240, so it works both ways, because they have the same terminal side. Alright, we'll try 17 pi over 6. Well, 17 pi over 6 is more than 1 time around, because 2 pi is 12 pi over 6, right? Maybe you convert the to 6th. So I have to take out 12 pi over 6, which leaves me with 5 pi over 6. Which means if I start with my initial side, I have to go 1 time around for the 12 pi over 6, plus another 5 pi over 6 to get my terminal side. So this is 17 pi over 6 when I go all the way around. Thus, going from here to here is 5 pi over 6, because it has the same terminal side from that initial. And if I go backwards here, going this way, that is a negative 7 pi over 6 for the other terminal angle. So essentially, for this angle, 17 pi over 6, there are 2 possible terminal angles from it, because they all share the same terminal side. Alright, let's try the negative pi over 2. So if I do the negative pi over 2, it's a little angle. I probably drew that too big there, but that's fine. Right there, that's my initial side, and that is my terminal side. Okay, we know that 2 pi is all the way around, so if I convert it to the 12ths that we have here, that would be 24 pi over 12, right? Since we know it has to be 360 all the way around, that means that this one going this way is 23 pi over 12. Oops, 12, not 24. So that is the coterminal angle there, because they both have the same terminal side. All right, pause the video and try these student problems. Okay, so the first student problem is 400 degrees, which is more than one time around. So we'll take out the 360, which leaves us with a 40 degrees. So if we start our initial side, we have to go all the way around 360, plus another 40 degrees. So there is our 400 degrees. So therefore, we have a coterminal angle of 40 degrees right here. And we also have one going all the way around this way is negative 320 degrees. Okay, negative 135, we have initial position here, and a terminal position approximately right there for, whoops, wrong one. Let's move that over. We have initial side here, and a terminal side right here for a negative 135. Again, that is our terminal side. That is our terminal side. So therefore our coterminal angle is 225 degrees, because again this must be 360 all the way around, and 225 plus 135 is 360. Okay, next one. Well, 13 pi over 5 is more than one time around. So therefore, if you use fifths here, 2 pi is 10 pi over 5, right? That's one time around, 2 pi. So I have to take out the 10 pi over 5, which is 3 pi over 5. So if I start with my initial side, and I go all the way around once for my 10 pi over 5, or 2 pi, then I have to go another 3/5, which is a little more than a half. So that gets me to right there. So that is my 13 pi over 5 to this terminal side. Okay, so we use the blue here. So this right here is 3 pi over 5. That's the coterminal angle, because it goes to the same terminal side. If I went the other way, which is negative, it has to add up to 10 pi, because that's 7 pi over 5 for the other coterminal angle. Okay, let's try the next one. So a tiny angle, negative pi over 15. Alright, so if we go all the way around, that's 2 pi. So in terms of 15ths, that's 30 pi over 15. That's 2 pi, correct? So if we go the other way, that leaves 29 pi over 15 is the other coterminal angle. Alright, and that is the end of Chapter 1, Section 1.